You should have this packet. I had given you a packet that has a classwork section and a homework section. So find your classwork section. That's what you're going to be taking notes on. Just a quick review of different types of roots, different types of numbers that we have in our number system. So natural numbers being numbers or also counting numbers, 1, 2, 3, 4, etc. Whole numbers, of course, just our natural numbers plus the number 0. Integers are whole numbers plus their opposites. Rational numbers are what we call anything that can be written in a fraction form, a over b, where a and b are both integers and b is not 0, which is why repeating decimals are rational. For example, 1/3 is 0.3 repeating. Irrational numbers, numbers that can't be written in fraction form, so like pi, square root of 2, anything that's a non-repeating decimal is irrational. Real numbers are all of the rational and irrational numbers together. Those are all real numbers. Then remember we talked about imaginary numbers, which the basic building block is I equals the square root of -1. And complex numbers is what all of them are. So sometimes we tended to think of complex numbers as just the imaginary part, but actually all numbers are complex numbers. So here's a really nice chart. I like this chart because you can just kind of start, like say you have a natural number like 12. 12 is a natural number. Then you just work backwards. It's also whole. It's also an integer. It's also rational. It's also real. And it's also complex. Now, we used in Algebra 2, we used a Q for rational because it's like a quotient. It can be written like a quotient. You can do that as well. We'll just write a Q there because then it's just one thing. For integers, we used a Z, and then that way when we dealt with irrational, but I'll just leave it with the irrational. So then the square root of pi, it's not real. It's irrational. So it's irrational. I just said it's not real. It's not rational. It's irrational, it's real, and it's complex. 12 over 25, it's not, it starts here at rational. So it's rational, it's real, it's complex. And this one right here, even though you want to look at this and think, oh, it's repeating, it's not. There is a pattern, but it's not like a repeating decimal. So this is actually irrational, real, and complex. -1 is an integer, so we'll start there. So it's an integer, it's rational, it's real, it's complex. Going through, well, I'll just go through these. So we have this one is rational. Oh, let me be consistent though. Rational, real, and complex. 4i is actually pure imaginary. There is no real number part. So this would be pure imaginary. The number 0 is whole, integer, rational, real, and complex. I guess I should put complex on this too. Pure imaginary is also complex. They're all complex. 0.3 is a terminating decimal, which makes that rational, real, complex. This 1.32 repeating, it's a repeating decimal, which makes it rational, real, and complex. 5 minus 3/4 I. It's not pure imaginary because it has a real number part and it has an imaginary part, so this one would just be labeled complex. And then this last one, you are taking the 4th root of a -32. So, you know what? I'm going to leave this one blank. I need to get back to you on this one because I'm thinking it's pure imaginary, but it's a 4th root, not a square root. And I think I remember looking and thinking that that's different. So we're going to leave that one blank. Moving on here, we define a root of a function as the value of x, which makes the function equal to 0. So remember that the root is the same thing as an x-intercept. So you might have a root of a function. It's the x-intercept if you write that as an ordered pair, the x-intercept of that function. And that also means we could say that it's a 0 of the function. We know that if a is a 0 of the function, then x minus a is a factor, and x equals a is a solution of f of x equals 0. So there's a lot of different ways that you can basically say the same thing. So if we had a parabola, f of x equals x squared minus 4, you set it equal to 0, you get 2 and negative 2. So then we could say all of these different things. We could say 2 and negative 2 are the roots of the function. 2 and negative 2 are the zeros. 2, 0 and negative 2, 0 are the x-intercepts. 2 and negative 2 are the solutions. X minus 2 is a factor and x plus 2 is a factor. All of those things would follow from that. If we had a cubic function, f of x equals x cubed minus x squared minus 6x, and we said f of x equal to 0, you can factor it, and we get our 3 zeros. And we can make all these following statements. We can say that the roots are 0, 3, and negative 2. We can call them zeros instead. We can say 0, 3, and negative 2 are solutions of f of x. We can say that 0, 0, 3, 0, and negative 2, 0 are all x-intercepts. And we can list them in factored form. So being familiar with that and knowing is extremely important. So then we have different types of graphs. This is linear. It will have one root. It's got 1, 0. A quadratic can have at most 2 roots. A cubic can have at most 3 roots. This is a cyclical, like this looks like it's the sine function. That one would have infinite roots because it keeps going. Or you can have a function, looks like a quadratic, and it has no roots because it doesn't cross the x-axis. So that's a possibility. When you do graph polynomials, remember polynomials are smooth and continuous curves. So these first two show a polynomial because it's a smooth curve. This is not a polynomial because it's not continuous. This is not a polynomial. It looks kind of like an absolute value graph because you have sharp corners. It's not smooth. I'm going kind of fast through these because this is a review. We've talked about this in the first few sections of Chapter 5. So a polynomial of degree n will have at most n real roots and at most n minus 1 turning points. So for example, the quadratic, here we have the graph of f of x equals x squared minus 4. And we know there are 2 roots, and you can see there's 1 turning point. The function f of x equals x squared minus 4x plus 4, that has 1 root because it's on the x-axis and 1 turning point. A cubic equation can have at most 3 real zeros, and you see one here that has 3 real zeros. You also can see one that has only 1. So, and this one has 1 real zero and it has no turning points. So there's, a variety of different ways that we can see that. So polynomials of degree 1, which are just linear functions. So if we needed to find the roots of the following, then you are just setting 5x minus 10 equal to 0. And we get x equals 2. So we could call that the solution. We could call it the root. We could call it the 0. We get negative 4x minus 3 equals 0. So then we have x equals negative 3/4. And here on this next one, we have x. When you solve this, we're going to subtract. Oh, we would first by setting it equal to 0. So I should start by doing that. And so when we solve for x, we're going to get negative 19.7 over negative 8.2. And if you just simplify this as a fraction, I did it ahead of time, you get 197 over 82, and I would just leave it like that. And on this one, this has no roots. And think about it. That should make sense. This is the horizontal line, y equals 4. It doesn't pass, there are no zeros. It doesn't cross the x-axis. So moving on to polynomials of degree 2, we have quadratic functions, and you guys are pretty familiar with this. So when we find the roots of the following, we have several different ways. In Algebra 2, we had a little chart with 5 ways to solve quadratic functions. So here, if I set this equal to 0, this is factorable. You can do a diamond problem. I get x minus 5 and x plus 3. So then we're going to get x equals 5 or x equals negative 3 would be our roots, which is also our x-intercepts. On this next one, you can, if I let x squared minus 100 equals 0, you can factor this. It's okay also to just say x squared equals 100 and square root both sides, as long as you remember that it's going to be plus or minus 10 when you do that. Also remember that this was factorable, the difference of two squares, x plus 10 times x minus 10, which would still yield the same two zeros. On this next one, I believe you can try factoring. Also, we're going to use, this is one where we're going to have to use the quadratic formula. So on this, when I set this equal to 0, I would get x equals the opposite of b, which would be -1, plus or minus square root b squared minus 4ac all over 2a. And when you simplify this, you get -1 plus or minus the square root of 97 all over 4. On this next one, this one is actually factorable with a modified diamond in a box. I'm not going to show all the work. We've done these before. So when you factor this, you end up with a 5x minus 4, and here you end up with a 2x plus 5. So I'm going to get, if I set the first one equal to 0, I get a positive 4/5, and the other one I'm going to get -5/2. So these were just all different ways. So remember that, all these different ways that we had, also finding using the quadratic formula. Now, when you do use the quadratic formula, you can actually tell something about the roots. So, and it's all going to depend on this right here, which is called the discriminant. And if the discriminant is greater than 0, then you're going to have two real roots. If it equals 0, you're going to have one real root. And because it would be if it equals 0, then it's just going to boil down to the opposite of b over 2a. And if it's negative, you won't have any real roots. You're going to have imaginary roots. So you can get information from that. Also, if b squared minus 4ac is a perfect square, then your roots will be rational because you'll be able to work it out. You'll be able to simplify it. So being aware of that, and again, that is all review. So on this next part, we are asked to find the number and nature of the roots and the actual roots, and then verify using a calculator. So for that first one, if we take a look at b squared minus 4ac, then we are taking b squared, so 23 squared minus 4 times 40 times -30. And we get 5,329. All right, so it's positive. I'm going to see if that's a perfect square. It is. So the square root, so this is a perfect square. So that means I know this. I have two real, rational roots. Okay? Find the number in nature and the actual roots. So I'm just going to do this part of it. I mean, you guys, well, okay. Now I'll let you guys, if you want to, I mean, you would know how to find those. We've done that before. So we're just going to identify what kind. You could use the quadratic formula and then figure that out, but you're going to have two real rational roots. So on this next one, we would have, for our discriminant, we're going to get b squared, so just be careful because it's parentheses, -24 squared. So b squared minus 4 times a times c, and I get 0. So the discriminant, b squared minus 4ac equals 0. So remember what that means. If you look back, if you get 0, that means we have one real root. Now remember how that would show up on a graph. If you only have one real root, then that means that, and this is opening up, that means my parabola is sitting on the x-axis. Then on part C, b squared minus 4ac, we're going to take -5 squared b squared minus 4 times a, which is 1, times c, which is -2, and I get 33. So what does that mean? That means I have two real roots, but since 33 is not a perfect square, that means I'd have a square root still in my answer because they're not going to be rational. And then on this last one, you can probably guess what's going to happen on here. I can, because there's only one we haven't seen yet. So b squared, so we have 1 squared, which is 1, minus 4 times a is 2 times 2, and I get negative 15, which means we're going to have 0 real roots, which, by the way, means we have 2 complex. Well, imaginary. They might not be pure imaginary roots. So we're going to involve I in that answer. Now we are finally to the place that it's a little bit new. Polynomials of degree 3, which are cubic functions. Suppose we wish to find the roots of f of x equals x cubed minus 3x squared minus 6x plus 8. So, we start off with, by inspection, you see that x equals 1 is a root. But we know that there might be as many as 2 more solutions. Remember, if it's cubic, then there's a potential to have, at the most, 3 zeros. So then the question is, how do you find them? Now remember what we talked about before is you can put one term in the box. So far, when we've done cubic functions, you have either been able to factor out a GCF, or you've been able to do like one number in each box and then factor it out. Well, now we're going to start seeing some that's not possible. So we're going to have to we need a method. So right now, they're going to start off by telling you the first solution. So we're going to say, all right, so suppose we know that x equals 1 is a solution. Remember, one of the ways that you can do that, if you evaluate f of 1, you get 1 cubed minus 3 times 1 squared minus 6 times 1 plus 8, which is what they did right here. And you get 0. And because f of 1 is 0, that means that 1 is a root, which means if we know that 1 is a root, then we know that x minus 1 is a factor. So we know one of the factors because we're going to try and factor this if it's factorable. So we're going to do division because we want to know what the other factors are. And one of the ways, the way to find that is to do division. So I'm going to do this right here, x minus 1, and we're going to divide that into this. We did this last year. I'm going to show you once this way. X goes into x cubed, x squared times. So you're thinking about what do I multiply x by to get x cubed? So if you remember the 4 steps of division, you divide, you multiply, you subtract, and you bring down. Those were the steps of long division. All right, so what we're going to do though, instead of subtract, we're going to change signs and add. We've done that before. So I divided, now I need to multiply. X squared times x is x cubed. X squared times minus 1 is minus x squared. Then we're going to change the signs and add. So when I do that, these cancel out and I get negative 2x squared. So that's that part. Now bring down. Then I go back up to divide. So x, I need to multiply by a minus 2x. And so that was the divide part. Now I'm going to multiply. I get negative 2x squared minus, plus 2x. Change the signs and add. And when I do that, these drop out and I'm left with negative 8x. Bring down, because that was next, back up to the top. So I would have to multiply the x by a negative 8. And if I multiply, I get minus 8x plus 8. And now I change the signs and add. And when I do that, they drop out and I get 0. Now, the fact that I have a remainder of 0 tells me it goes evenly. So now what do I know? Well, I know that x minus 1 is a factor, and I know that x squared minus 2x minus 8 is a factor. So then I have to think, well, can I factor x squared minus 2x minus 8? Well, that I'm going to try with a diamond problem. And two numbers that would multiply, so we have a negative 4 and a positive 2, because that multiplies to negative 8 and adds to negative 2. So I don't need a box because it was just an x squared. So I get x minus 1 times x minus 4 times x plus 2. So those are that's how I would factor that. And which would mean that my solutions, x equals 1, 4, and negative 2. So those would be, I would have 3 zeros or 3 roots for that particular problem. Now, that was long division. We did something called synthetic division, which is much better. I'm going to show you that. So to do this synthetically, we're going to take the opposite of this. So we're going to take a positive 1 out front and do this upside down kind of division here. So remember to take the opposite when you do that. Opposite. And then you're going to put the coefficients here. This, remember, is a 1. So I have a 1x cubed, negative 3x squared, negative 6x, and a positive 8. If I had skipped a power, I would have to leave a 0 in there. Then you bring down the first number. And then you're going to multiply. 1 times 1 is 1. You multiply. And then you add. Negative 3 plus 1 is negative 2. And then you're going to just go back. Multiply. 1 times negative 2 is negative 2. And then add. Multiply. And then add. So you don't go back up to the bring down. You just go multiply, add, and you keep going. Now, what we're hoping, this is our remainder. So we're hoping to have a remainder of 0, because if we didn't have a remainder of 0, then 1 would not have been a root. So notice what I have left here. So we already know that this is x minus 1. And now we know that this is, you're going to put it back into the polynomial. We get x, since this was x cubed, you drop it down 1 power, x squared, minus 2x minus 8. And this actually has a name right here. This thing, this x squared minus 2x minus 8, is called the depressed polynomial. It's not sad, not that kind of depressed. Okay, so that's what you would do for, and then you would do a diamond problem like I already showed you and I did to finish factoring it. So I'm just going to kind of read through this, follow along. The fact that you ended up with a remainder of 0 tells you that x minus 1 divides evenly into x cubed minus 3x squared minus 6x plus 8. The numbers at the bottom represent the coefficients of the answer. The solution is, and so these were the 1, the negative 2, the negative 8. Those were those numbers we got. And so that's that you put that back into a polynomial. And so then we have it factored as x minus 1 times x squared minus 2x minus 8. And then you factor using other things you already know how to do. So now we have it completely factored. We know the roots are all rational and real. And if you graph it on your calculator, you would see that it passes through those you can see the shape of that. And I know you guys can do that part. So here's some practice problems we're going to do, and we're just going to practice with synthetic division. So we're going to take the 2 out front, and my coefficients are going to be 1, negative 3, negative 6, and 8. So I bring the first number down. I usually leave like a little space, and then I multiply and add. Multiply and add. Multiply and add. So my answer, notice that this answer, this tells me that x minus 2 is not a factor, because I got a remainder this time. I got a remainder of 8, of actually negative 8. So when I write this back down, to write down my answer, this was x cubed, so I'm going to have 1x squared minus 1x minus 8. And then what to do with the remainder? Well, I'm going to write it as a minus 8 divided by, and I have to put what did you divide by? Now, not the fake division, synthetic division, but the x minus 2. You're going to go back up here. So you're going to write down the values, these are the coefficients of your answer, and then whatever your remainder is, you put by what you divided by, and in this case, it was x minus 2. For the next one, the opposite of this positive 3, we're going to put a negative 3 out front. My coefficients are 1, negative 2, negative 21, negative 18. Bring the first number down, multiply, and add. Multiply, and add. Multiply, and add. Notice I got 0. What does that tell me? If I got 0 as a remainder, that means x plus 3 is a factor. My answer is x squared, because remember you drop it down to power, minus 5x minus 6. So that would be my answer. Now all we're doing is practicing synthetic division. We're not having to go on from that. You know, I'm not finishing off a problem, and synthetic division is the tool, and we're just learning the tool right now. So this was my answer. So on the next problem, the opposite would be a negative 2. And my coefficients, I have a 1x cubed minus 4x squared minus 28x and a minus 30. Bring the first number down, multiply, and add. Multiply, and add. Multiply, and add. So I don't get 0 that time. I got 2. I got a remainder. So I'm going to take, my answer was the first number is a 1, drop the power down, so it's going to be a 1x squared minus 6x minus 16. This was a positive 2, so it's going to be plus 2 over, don't put a negative 2 here. Remember, we were really dividing by x plus 2. Next one. We're going to have a 4 out front. We have a 1x cubed, and there are no x squared, so I have to leave a 0 as a placeholder. And then we have negative 12 for the x and a minus 16. So I bring the first number down, I multiply, and I add. I multiply, I get 16, and I add. I multiply, I get 16. Oh, notice I get a 0. That's going to be important for where we're headed with this, because we want to get a 0, because then we would know x minus 4 was a factor. But right now, again, we're just practicing the division part. So I would have an x squared plus 4x, because it descends by power, plus then this 4 would be a constant, and that would be my answer. On the next one, we're going to have a 3 out front, and we have a 1x to the 4th minus 1 minus 22. Whoops, that's a little more than we need. Plus 16 and a minus 96. Okay, so those are all of our numbers. So we bring the first number down, and we multiply, and we add. And we multiply, and we add. And we multiply, we get a negative 48 here, and when you take a positive 16 and a negative 48, you're going to get a negative 32. And when you multiply 3 times negative 32, you get negative 96. Notice these are not opposites, though, and we're adding. So you get negative 192. So that's not a 0. That's going to be, we're going to have a remainder there. So my answer, drop the power down 1, so it's going to be x cubed plus 2x squared minus 16x minus 32 minus, and I take my remainder and put it over what I divided by. On this last one, we have to treat this a little differently because of this 2 right here. So we can't just do synthetic division until we fix that. And what we're going to do is we're going to start by dividing everything by 2. So I'm going to write it out this way. 2x cubed minus 11x squared plus 17x minus 6 divided by 2x minus 1. And I'm going to now divide everything by 2. So then what we're going to end up with is a 1x cubed minus 11 halves x squared plus 17 halves x minus 6 halves is 3. And we're dividing by x minus a half. So everything divided by 2. From there, now I set up my synthetic division. So I'm going to have a positive a half out front. Don't let the fractions bother you because they just kind of work out. So I would have a 1x cubed, a negative 11 halves for the x squared, a 17 halves for the x, and a minus 3. Bring the first number down. Half of 1 is a half. Negative 11 halves plus 1 half, notice they already have common denominators. I get negative 10 halves, and negative 10 halves is just negative 5. So then I multiply half of negative 5. Leave it as negative 5 halves, because then I have my common denominator. 17 halves minus 5 halves, we end up with 12 halves, which is 6. Half of 6 is 3. And when I add those together, I get 0. So this is my answer once I put it back. So if this was cubed, now this is squared. So I get x squared minus 5x plus 6. And that would be my answer. So remember, because we got 0 as a remainder, if our goal was factoring, I would have x squared minus 5x plus 6, and then I could attempt to factor that some more, and I would have 2x minus 1 would have been another factor. So that is how you do those problems. Your homework assignment is from the textbook, and it is practicing synthetic division problems, so or practicing division problems. So that is what you guys will be doing. Okay, actually looking into your homework assignment, a lot of them, this first chunk of problems are just synthetic division to find the answer. Then there are a few problems, like in this section, they ask you to use synthetic division to determine whether the first expression is a factor of the second. So for example, on number, like if I had assigned 38 to you, you would take a 2, because you do the opposite, and you would do synthetic division. And remember, you're looking for 0 to get 0 as a remainder. If you get 0 as a remainder, that tells you that x minus 2 is a factor. And it says if it is, indicate the factorization. That means you would write it out kind of like I did on that first example where I wrote it out in factored form with the x minus 2 and then whatever you get as an answer, the depressed polynomial. And you could go ahead and attempt to do the complete factorization if you ended up with something with a quadratic and you tried a diamond problem and factored it. On these graphical ones, you can tell, like on number 46, I don't know that I didn't assign that one, but I think you have to do perhaps 45. You can see, like on 46, notice I can see 2 works. 2 is a root. So if I do synthetic division with a 2, I should be able to write the factored form of the polynomial. So I know that x minus 2 would be 1. I can do synthetic division and come up with the other if possible. Then I think you guys would be okay with that, but they weren't all just strictly division. There's a few additional things, but we've talked about that. So you should be successful with this.